Number 28. 28. If 29.0 liters of methane, which is CH4, undergoes a complete combustion at this pressure and this temperature, how many liters of each product are formed? Wait, I get a volume, a pressure, a temperature. Does that mean I'm going to use PV is equal to nRT? Let's think critically about this. We're doing section 3 stuff, about gas stoichiometry. We're trying to use the idea that as long as temperature and pressure are the same, we can treat the coefficients of a balanced chemical equation, which we would normally use as mole ratios, we can actually use them as volume ratios as well. So all the question's really doing is telling you that pressure stays the same, temperature stays the same. So if we get ourselves a balanced chemical equation, we can use those coefficients as volume to volume ratios and convert that way. So here we go. So we have methane, CH4. It's a complete combustion, so that means it's going to react with O2. And as long as we're combusting a hydrocarbon, right? Hydrocarbon. The two products are always going to be carbon dioxide and water. Now let's see, to balance these bad boys, 1 carbon, 4 hydrogens, 2 hydrogens, so I'll double that. So I got 4 hydrogens on each side. I have 1, 2, 3, 4 oxygens on this side, so I'll need to put a 2 there. So I got a 1 to 2 to 1 to 2 ratio. So this is actually asking for each product, so I'm going to generate 2 different answers here. I'm going to generate a volume of CO2 and a volume of water. So let's start with what was given to me by the problem. Gosh darn, what I've written 2 a couple times now. So I want to cancel out liters of CH4 and go into liters of, let's do CO2. That way liters of methane cancels. My answer will be in liters of CO2. Now what is my ratio? That's a 1 to 1. So I don't even need my calculator. 29.0 liters of carbon dioxide. But the question asks for each product, so I also need to do water. Again, starting with 29.0 liters of methane. Convert out of liters of methane and into liters of water. And actually find that this is a 2 to 1 ratio. And so this actually doubles. 58. Now I'm using 3 sig figs in each of my answers here because 3 sig figs were given to me by the equation. And remember, the only reason I was able to use the coefficients of the balanced chemical equation for this number 28 is because we had the same temperature and pressure going on, right? And so as long as we have the same temperature and pressure, we can compare the characteristics of gases using volume to volume ratios.